the next important topic is magnetic field at the center of circular current carrying loop, right? Circular current carrying loop. Suppose this is the circle, the current carrying is I, all right, like this. If it is the current, the radius is to be R. To find the magnetic field at the center, you will consider the small current carrying element of the length dl, right? Because of this length dl, this is the, suppose the r distance or the position vector where we have to find the magnetic field. So what is the angle? According to Biot-Savart's law, Biot-Savart's law, what is that? Mu naught I dl sine theta upon 4 pi r square. Is it clear? Tell me, what is the theta? If this is the dl vector, this is the r vector, dl, and this is the r. If this is the dl vector, this is the r vector, what is the angle? 90 degree, right? Theta is what? 90 degree. So mu naught I dl sine 90 upon 4 pi r square dB. Are you getting or not? What is sine 90? 1. It is equal to 1. Mu naught I upon 4 pi r square into dl. What is the dl? Is the elemental length. To find the, this is the magnetic field due to this small portion, elemental portion. But there will be so many portions. Because of this, the magnetic field into the board, into the board, into the board. So you have to find the summation of all the magnetic field. Summation mean integration. So if this is the elemental magnetic field due to elemental portion, to find the net magnetic field, you have to what? Add them. You have to sum them. You have to integrate them. Are you getting? If you consider this is the portion, this is the constant, it comes out from the integration. And if this is the dl, what is the total integration of this dl? 2 pi r. So it is equal to mu naught I upon 4 pi r square into 2 pi r. When you will simplify this, 2 pi will cancel out, r will cancel out. So the magnetic field at the center is mu naught I upon 2r. You have to remember, right? Copy this. So this is the magnetic field due to the complete circle at the center, right? If we ask, due to the magnetic field due to the semicircular loop, tell me how to find.
So integration would be from 0 to pi r of dl.
Yes, you can say 0 to pi r, that is also correct. Then the 2 and 2 will be cancelled out, so the 4 will come.
Yes.
Directly you can say, if it is the total magnetic field due to the circle is, say, mu naught I upon 2r, due to the half semicircle, mu naught I upon 4r. Is it clear or not?
Yes.
And due to the quarter circle, tell me.
U naught I upon
8r, just half of this, right? If this is the I, the quarter circle mu naught I upon 8r. But due to the circular arc, how would you find? Circular arc making angle theta. Circular arc, right? This is the circular arc, not complete circle, rather it is a portion of circle. Current is I making angle theta and the radius is r. Is it clear or not, you tell? So what will be the magnetic field due to this portion, you tell? Listen, how to find. If it was the complete circle, the angle made by the complete circumference at the center is 2 pi. So when angle is made 2 pi, right, the magnetic field at the center is mu naught I upon 2r. This is the magnetic field due to the full circle. And if the angle is 1 radian, mu naught I upon 2r upon 2 pi. Are you getting or not? Unitary method I am using. And if it is theta, what is the magnetic field? Multiply by theta. And this is the magnetic field at the center due to the circular arc, current I, theta upon 2 pi. Is it clear or not? Now listen one thing. If theta is 2 pi, that is the complete circle. Getting? 2 pi will cancel out. Magnetic field is mu naught I upon 2r. Here, what is this? Is the circular arc making angle pi. So if you put here mu naught I upon 2r, pi upon 2 pi. So what is the magnetic field over here? Mu naught upon 4r. Is it clear or not? Just half of the circle. And here what is the theta? Pi by 2. So how to find? Mu naught I upon 2r, pi by 2 upon 2 pi. So what is the magnetic field at the center now? 8r. Is it clear or not?
Yes.
Now, if this is the circular arc making angle 30 degree, the current is I, radius is r. So what is the magnetic field over here? Mu naught I upon 2r is due to the complete circle.
Yes.
And due to the theta, say theta upon 2 pi. Is it clear or not?
Yes.
And in place of theta, what will you put? Pi by 3.
Yes.
So it is mu naught I upon 3 दूनी 6, 6 दूनी 12. This is the magnetic field at the center. Is it clear or not, you tell?
Yes.
Copy this. So read this question. In this question, the arrangement made up of two identical coils shown in figure. So one coil is like this, in the horizontal plane. The current is I. This is the coil 2 as shown in figure, right? And the another coil is this. The current is like this. And this is the coil 1. Is it clear? So you have determined the magnetic field at the center O. Here, right? This is suppose the x-axis. This is supposed to y-axis. The magnetic field you have to find at the center O. Is it clear or not, you tell?
Yes.
Suppose the number of turns in the coils are n. The current carries is capital I. You can think this is the capital I. Are you getting or not?
Yes.
So listen one thing. If this is the circular coil, the current is I. So here the magnetic field is what? Say upward,
Yes.
right? So this is the magnetic field. Fine. If this is the current carrying coil, the current carrying coil is like this and the current is like this. So the direction of magnetic field like this, right? Are you getting? So because of this coil, the magnetic field is in this direction. Because of this coil, the magnetic field is in this direction. So what is the resultant magnetic field? B root 2. B root 2. And what is the value of B? Say mu naught I upon 2r is due to the circle, one loop. And if it is a coil mean n turns are there, right? So multiply by n. So what is the magnetic field? N times mu naught I upon 2r, right, into root 2. Is it clear or not?
Yes.
Listen one thing. Sometime there may be the problem in the direction. If this is the current I, right, here the magnetic field are emerging like this. Is it clear or not?
Yes.
So if the current is in this direction, anti-clockwise it is moving, it is flowing, so it is upward direction, right? And if you consider this is the thing, right? Suppose the current is in upward in this direction, so because of this the magnetic field will be in this direction. Are you getting or not? So here the magnetic field will be like this, but this is the current carrying coil. In this current carrying coil, the current is flowing like this. Are you getting? So here the magnetic field are emerging like this. Getting or not? So at this point the magnetic field is in this direction, and because of this the magnetic field is in this direction. Is it clear or not? Then their resultant is B root 2. Copy this. So read this question. The magnetic induction at the center of in the given figure. This is the 3/4 of the circle, right? And then this is the another quarter of the circle. Its radius is A, its radius is B. The current is I in this way. Is it clear or not, you tell? If this is the circle, this is the circle. If you consider this is the portion, so because of this small portion, this point lies on the line of this portion. So because of this portion, the magnetic field at the line. And in the same way, if you consider this is the small state portion, the magnetic field is 0. Because of this portion, the point lies on the line of this current I. Is it clear or not? So magnetic field is due to this 1/4 circle, and this is the 3/4 circle. So tell me, if this is the 3/4 circle, right? Like this. Fine. Like this, like this. So what is the angle made? If this is pi by 2, what is this angle? 3 pi by 2. You are getting or not? So if this is theta, so due to this circular arc, magnetic field due to the first portion you can assume is what? Mu naught I upon 2a. This radius is what? A into theta upon 2 pi. What is the theta over here? Tell me. What is the angle made by this portion on the center? Say 3 pi by 2 divided by 2. Is it clear or not, you tell? Yes. Oh, sorry, it is 2 pi. So answer will be mu naught upon 2a, 3 upon 4, 3 mu naught I upon 8a. Is it clear? Yes. B1 is equal to 3 mu naught I upon 8a. And the direction is what? Into the board. Right. Now consider this the second portion. This is the second portion. What is the angle made on the center? This is the quarter circle. Right. This is quarter circle, and the radius of this circle is B. And what is the direction of the magnetic field? Yes. How? This is the current. This side is into the board, and if you consider this side is right. This side is into the board, and the magnetic field this side is out of the board. Due to this out, due to this in. But we have to find this, so into the board, right? So if you consider the second portion, so due to this second portion, right? Due to this second portion, the magnetic field is mu naught I upon 2a, and the radius is what? Say 2b, and the theta upon 2 pi. What is the theta over here? Say pi by 2. Pi by 2. Pi will cancel out, so mu naught I upon 8b. This is into the board, this is into the board. If you take this into the board positive, this magnetic field also be positive. So what is the total magnetic field at center? Say plus and plus. 3 mu naught I upon 8a plus mu naught I upon 8b. Is it clear or not, you tell? So this is the answer, right? Copy this. So read this question. In this question, a wire in the form of circular arc. This is the wire in the form of circular arc, right? Like this. And this is the straight wire AB. This is the radius R. This is the angle theta. This is the angle theta. This is the current I and this is current I. Is it clear or not, you tell? So you have to find the magnetic induction at point O. Fine. So if this is the wire AB, the radius is R. So what is this perpendicular distance, you tell? To find perpendicular distance, first I will consider this is the portion B and A, and this is the perpendicular distance D. The current is I into the board, right? So what is theta 1 and what is theta 2? Say theta theta. Fine. In this triangle, the cos theta is what? Say base upon hypotenuse r cos theta. So this is the D. So because of this first portion, the magnetic field is mu naught I upon 4 pi D, right? And this is sine theta plus sine theta. Getting or not, you tell? What is the value of D? This perpendicular distance in terms of radius, 4 pi r cos theta into 2 sine theta. Is it clear or not? B1 is mu naught I upon 2 pi r tan theta is into the board. Is it clear or not? Okay. So this is the magnetic field due to the straight wire. Now we have to find the magnetic field due to this circular arc. So what is this angle, you tell? 2 pi minus 2 theta, right? So due to this angle we have to find the magnetic field, and the magnetic field due to this circular arc is what? Say it is also into the board, it is into the board. So due to circular arc, please tell, the B is, this is the second portion, suppose mu naught I upon 2r and theta upon 2 pi. What is the theta over here? Say 2 pi minus 2 theta, right? So mu naught I upon, simplify, this is 2 pi r pi minus theta into the board. This is the B2, right? If it is into the board, positive. So if it is into the board, positive, so the net magnetic field at center is what? B1 plus B2. The B1 is mu naught I upon 2 pi r tan theta, mu naught I upon it is 2 pi r pi minus theta. So if you take common, mu naught I upon 2 pi r tan theta plus pi minus theta is left. So this is the magnetic field at the center and the direction will be into the board, right? Copy this. So read this question. In this question, write a long wire band as shown in figure and carries current I. Suppose this is the Y, this is X and this is Z. Are you getting? This is the O, this is the current I is flowing in this way. This is the another wire carrying current I in this direction, and this is the another part. The current, same current, it is minus infinity, right? It is infinity like this, right? From infinity they are coming. Are you getting or not? From infinity to infinity. So we have to find this current at point C. The radius is A, right? The semicircular distance, this is A. Is it clear or not, you tell? So how many portion is there in 3? 1, 2 and 3. Is it clear or not, you tell? Now first consider this system. This system is in what? Say this is Z and this is Y. The current carrying wire system is like this. Is it clear or not? So the magnetic field due to this semicircular loop will be into the board or not? This is the X. This is the X, Y and Z. So because of this, the magnetic field will be into the board. This is the second part. The B2 will be due to semicircle mu naught I upon 4R and the R is A. If this is the X, its direction is minus X. So in vector form, you will write mu naught I upon 4A minus I cap, Tesla. Is it clear or not, you tell? Right. First copy this. So now consider the first portion. If you consider the first portion and the third portion, if you consider this portion, both two portions are in which plane? This is X, this is Y, right? This is X, this is Y. So this is the first portion is going in this way. And this is the distance. What is this distance? Say A. So this is what? Say semi-infinite wire. Are you getting or not? And the other wire, this is the third wire. The current is in this direction, right? This is also the semi-infinite wire. Because of this current carrying, magnetic field is into the board, and because of this, into the board. And due to semi-infinite wire, the B1 magnetic field I am writing this side. What is that? Mu naught I upon 4 pi A. A is the. And B3, due to this also mu naught I upon. And the direction is, tell me, into the board. Into the board. And if this is XY, XY, this is Z. And the direction is into the board. So this is minus K cap. This is minus K cap. So this is minus I cap. So how would you write the total magnetic field at point C is equal to what? B1 vector, B2 vector plus B3 vector. Getting or not? So B1 and B3 both are equal. Mu naught I upon 4 pi A minus K cap, mu naught I upon 4A minus I cap, plus this is the B3, value is mu naught I upon 4 pi A minus K cap. Is it clear or not? So if you take mu naught I upon 4A common, this is 1 upon pi minus K cap minus I cap, plus this is also equal to minus K cap upon pi, right? Minus 4 pi A. So answer is mu naught I upon 4A minus I cap minus 2 upon pi K cap. Tesla is the magnetic field at point C. Is it clear or not, you tell? Copy this. So read this question. In this question, the magnetic field at the center of a circular current carrying coil of radius R, right? Suppose the current is I, here the magnetic field is B1, and if you take the another coil of the radius R by 2, the same current is carrying. So the magnetic field is into the board is B2. So B1 is what? Mu naught I upon 2R, right? And it is B2 is equal to what? Right? Same current is carried, mu naught I upon 2R by 2. And this is equal to 2 mu naught I upon 2R. If it is equal to B, you assume. So therefore, the B2 is equal to 2B. What they are asking, B1 upon B2. So it is B upon 2B is equal to 1 by 2. So the first option is the correct option, right? Copy this. So read this question. In this question, a coil of 1 ton is formed by the length of the wire. The total length of the wire, if you consider the radius, the total length is given of 6.28 meter, right? It is equal to 2 pi meter, right? And therefore the L is nothing but equal to 2 pi r. So L is 6.28 and 2 into 3.14. So the radius is also equal to, it will cancel out, right, 1 meter. Fine. And the current carries, right, what is the current here? It is equal to 3.14 ampere, and they are asking what? The magnetic field at the center of the coil. So B is equal to what? Mu naught I upon 2R. What is the value of mu naught? Say 4 pi into 10 to the power minus 7. What is the current? Current is and the radius is 1. So it is equal to 2 pi into 3.14 into 10 to the power minus 7, right? 4 to the 2. So it become 2 into pi square into 10 to the power minus 7. And the pi square is approximately 10. So it is 2 into 10 to the power 2 into 10 into 10 to the power minus 7 minus 6 Tesla, right? So the fourth option is the correct option. Copy this. So read this question. In this question, the length of the wire is over there. It carries a steady current and it is now bent to form a 1 ton. So from this wire, the 1 ton is formed, right? And when the 1 ton is formed, the current is I, the magnetic field is B1, suppose. So B1 is equal to what? Suppose the radius is R. What is the B1? Say mu naught I upon 2R. Is it clear or not? Now, with the help of the same wire, suppose the wire is AB, the 3 turns are formed, 1, 2 and 3, right? You may assume 1, 2 and 3. The radius is supposed to be R2. Now the number of turns here are 3. Are you getting? The current is same. So what is the magnetic field B2 over here? Can you tell me? Yes, due to 1 turn, mu naught I upon 2R2. All right. And how many turns are there? Say 3. The same wire is used to form the 1 turn. The same wire used to form the 3 turns. Is it clear or not? So if you assume the radius is to be R1, right? And in this case, the radius will be R2, which will be less than the R1. What is the relation between R1 and R2? Suppose this is the length. The length is nothing but 2 pi R1, right? The length of the wire. And here the same length is equal to what? 2 pi R2 multiplied by 3. Is it clear or not? Here are the 2 pi R2, 2 pi R2, 2 pi R2, 3 turns. So 2 pi R1 and 3 into 2 pi R2. So 2 pi cancel out, R1 is equal to 3 R2. So this is the relation between R1 and R2. Now if equation number 2, equation number 1 divided by 2 and 1, right? B2 upon B1. What is the B2? 3 mu naught I upon 2R2 divided by mu naught I upon 2R1. It is equal to, everything will cancel out except R1 and R2. 3 upon R2, it is 1 upon R1. What is the relation? R1 is nothing but, this is R2. R1 is nothing but 3R2. So B2 upon B1 is nothing but 9. So the magnetic field this time become 9 times, right, of B1, right? Copy this. So read this question. In this question, 2 concentric coplanar coils of equal ton having radii, this is the 10 centimeter suppose, this is the 30 centimeter suppose, right? There are 2 concentric coil, same current flowing in the both coil in the same direction. Suppose this is the initial direction of the current, suppose, now the current is reversed in one coil, then the ratio of magnetic field at their common center in two condition. Okay, suppose this is the R1, the R2. R1 is 10 centimeter, R2 is 30 centimeter. Here the current is flowing, right? The same current is flowing in the same direction. So magnetic field is what? If you consider, the magnetic field will be into the board, right, like this and like this. So both magnetic field will be in the B1 and B2 in the same direction, or not, you tell, right? Or you can make the figure like this. Suppose this is the one current, one coil. Initially the current is I, the radius is 10 centimeter, the radius is 30 centimeter. In this case the magnetic field will be what? Say into the board, due to the both, this is the one coil, this is the second coil. So in the B1 is equal to mu naught I plus 2R1 mu naught I upon 2R2. Is it clear or not, you tell? But in the second figure, the now the current of the direction of current is reverse in one coil. Suppose this coil is reverse, right? And this coil, if the current in this coil is reversed, so magnetic field will be, right, out, and because of this the magnetic field will be in. This is the second coil, this is the one coil. Are you getting or not? So in this figure, this is the first magnetic field at the center net. In this figure, due to this big coil, the magnetic field is mu naught I upon 2R2. Are you getting? Right. Minus mu naught I upon 2R1. Is it clear or not, you tell? So now we have to take the magnitude, right? We have to take the magnitude. So what they are asking, the ratio B1 and B2, when both current when the current in both coil in the same direction, they are helping. So mu naught I upon 2R1 plus mu naught I upon 2R2, right? But when one direction is reverse, then their subtraction we have to take. Whether you can choose this the R1 or R2, right? Mu naught 2R1 minus mu naught I upon 2R2. The current in the both coil is same. So what? How to find the answer? 1 upon R1 plus 1 upon R2. 1 upon R1 minus R2. So it is R2 plus R1, R2 minus R1 if you simplify. The R2 is what? Say 30 plus 10 upon 30 minus 10. Right? Mode we have to 40 upon 20 is equal to 2. So what is the ratio of the magnetic induction in the first case and the second case? 2:1 is the correct answer, right? Copy this. So read this question. In this question, two concentric coplanar coils. Suppose this is the one coil, right? Coil mean number of turns are more, right? More than one. If the number of turns is N1 and N2, equal current in both current. Suppose this is the current I and the current I. Both current having the opposite direction, but the magnitude of the currents are same. So because of this, the magnetic field will be into the board, right? And because of this, the magnetic field will be out of the board. All right. And the radius R1 and R2. Are you getting or not? Wait for 1 minute. The ratio of the radius is 2:1. It means, and the number of turns is N1 and N2. So number of turns you may suppose to be N, and the number of suppose to be N2 over here, right? Because the ratio of, assume this is the radius R1 and R2, because R1 upon R2 is 2:1. So R1 radius is big, right? And R2 radius is less. Is it clear or not? Now you assume this is the coil 2 and you assume this is the coil 1. So because of coil 2, because of a small coil, the magnetic field is into the board, B2 is into the board, right? And B1 is what? Because of this current, B1 is out of the board, right? So if the net magnetic field is 0, what does it mean? It is B1 minus B2, right? or you can say B1 and B2 both are equal. So what they are asking, the number of turns N1 and N2 they are asking. So B1, because of this, the one due to one current carrying loop mu naught I upon 2R1, right, and because of number of turns it is N1, and due to one coil, the second coil mu naught I upon 2R2, and number of turns are N2, both are equal and opposite direction. So N1 upon R1 must be equal to N2 upon R2, implies that N1 upon N2 must be equal to R1 upon R2, right? And what is the R1 upon R2? Is equal to 2:1. So N1 upon N2 is equal to 2:1 is the correct answer, right? So the first option is the correct option, right? Copy this. So read this question. This is the part A we are discussing. You have to find magnetic field at point O for the following circuit loop. So this is the first diagram, right? Like this, and the radius, this is the point O, the radius is R. So listen, this is the one part, this is the two part, and this is the three part. So here we have to find the magnetic field at O. All right. So this point O lies in the line of wire, right? So the magnetic field due to this part is 0, and this is also the infinite part from here to here, and the point O lies on the line of the wire, right? So the B3 will be 0. Fine. Only the magnetic field is due to the semicircular path, and it is into the board. So if you consider the B2, due to the semicircular path, the magnetic field is mu naught I upon, tell me,
mu naught I upon 4R.
4R. And what is the direction? Into the board, right? Inwards, right? So the net magnetic field at O is B1 plus B2 plus B3. I think you understand. This is mu naught I upon 4R plus 0. So at the point O, the magnetic field is mu naught I upon 4R into the board, right? Copy this. So in this part, right, again, this is the B part, you can say. This is the infinite wire, semi-infinite wire, current is coming I. So this is the one part. This is the quarter circle, assumed to be the second part, and this is the another infinite wire. The current is I, assume this is the third part. So this is the point O, radius is R, this is 90 degree. So we have to find the magnetic field at point O. All right. So how to do that? Consider this only the first part. Because of this first part, suppose this is the infinite part. All right. So at this point, distance R. What is the magnetic field due to the first part? Please tell. It is coming from infinity, the current I. Tell me, it is semi-infinite wire for this point P. Current is downward. What is the direction of magnetic field? This is out. If you take the current here, the left side, it is into the board, and it is the right side out of that. So here, because of this, B1 is what? Tell me, what is the magnetic field due to semi-infinite wire?
Not I upon 4 by
R.
R.
And this is outside. Is it fine?
Yes.
Listen one thing. This is the second part. The second part is quarter circle. Fine.
Yes.
And because of this quarter circle, you tell, this is the point O.
What is not I upon 4
4R. Yes. But what is the direction? If this is the current carrying loop, this side the magnetic field is into the board, this side magnetic field is out of the board. At point O, it is into the board. So because of this two part, B2 is what? Due to quarter circle, mu naught I upon Tell me.
4R.
Yeah, mu naught I upon 2R is due to,
Full. Yes, sir. 8R.
yes, right, due to semicircle 4R. So it will be what? Say 8R. And what is the direction? Say into the board. Is it clear or not?
Yes.
Now the third part is left. So this is the third part, right? This is also this point O at distance R, and this is what? Semi-infinite wire, right?
Yes.
This is the third part. Can you tell me, due to this semi-infinite wire, what is the magnetic field at this point?
U naught I upon 4 pi R into.
Yes, this is the current carrying wire. It is this side into the board, this side outside the board. But the point O lies this side. So because of this, mu naught I upon 4 pi R, and this is into the board. Is it clear or not? This is out, this is in, this is in. So the total magnetic field, you have to take the vector sum. If you consider the out to be the positive, then in you have to take with negative sign. So then what is the net magnetic field at O? You tell. B1 plus B2 plus B3. It is taken with minus mu naught I upon 4 pi R, right? Plus mu naught I upon 8R, and this is plus mu naught I upon 4 pi R. Yes, they cancel. It is mu naught I upon 8R. It is plus, and we are taking the into the board. It is plus. So this is the magnetic field at the center, right? Copy this. So this is the next part A. Here, this is the small semicircle. This is the big semicircle. The current is flowing like this. Is it clear? And this is O, radius R. This is capital R. This is 2R. We have to find the magnetic field at this point. Is it clear or not, you tell?
Yes.
So this is the one part, and the point lies on the line. So if you consider this the one part, this is the two part, and this is the third part, right? So because of one part and the two part, what is the magnetic field here? 0. So only the two part, and you consider the third, this is the fourth part, the magnetic field is there. So because of second part, the magnetic field is out of the board. Please tell. The current is out of the board. And what is the magnetic field due to the second part? Tell. Mu naught I upon 4R.
4R.
Yes, right. And it is out of the board. Fine. And now this is the semicircle again. So at this point, the current is I in this direction, out of the board, right? So due to the fourth part, mu naught I upon 4R, but the radius of this semicircle is what? 2R. This is out of the board, and the B1 and B3 both are equal 0, right? So both are in the same direction. If you take this the positive, it must be positive. So what is the B magnetic field at O? This plus this, right? Mu naught I upon 4R plus mu naught I upon 4 2 ja 8R, right? So 3 mu naught I upon 8R, and it is out of the board. This is the answer. Copy this, right? So this is the B part. This is the second of B part. In this case, again, this is the semicircle. The current is in direction, in this direction. Now, this is the current I. The current I is over here, right? So, like this. The radius is R. It is 2R. Are you getting or not? You tell. Please tell. Now, because of a small part and because of a small part, are you getting?
Yes.
if you consider this the 1, 2 part, 3 part and 4 part. So because of 1 and 3 part, magnetic field is 0. So only because of this semicircle, yes, this is the current I. What is the magnetic field? I am telling you the direction. If this is the I, so left or right. So this side the magnetic field is into the board, and this side out of the board, this side into the board, this side out of the board. So because of this, the magnetic field is what? B2. Tell me. Out. And what is the magnitude due to semicircle? Mu naught I upon 4R. The R is R over here, and this is out. Getting? And if you consider the big circle, big semicircle like this, the current direction is in this way. Here, this is the point O. So the current I is in this direction. It is out of the board. It is into the board. It is out of the board. Right. So here into the board. So this is the fourth part. So B4 is nothing but mu naught I upon, say, 4R. But what is the R for the big semicircle? 2R. And this is what? Say, into the board. Right? Which is greater, B2 or B4, you tell? B2 is greater. No. B2 is greater. Yes. So you may assume it is positive. It is out positive. And you may assume in is negative. Right? So, and B1 and B3 is what? 0. Right? So what is the B net? This is the mu naught I upon 4R, positive, minus mu naught I upon 4 दूनी 8, 8R. Right? So 2 mu naught I upon mu naught I. If you take the 8R LCM, fine. Mu naught I upon, this is the B1. Right? And what is the direction? Say the direction is positive, mean out. It is positive, it is negative. So if total magnetic field is coming positive, it means it is out. Are you getting?
Yes.
It is not necessary into is always taken as positive. If you are taking one direction is positive, so another direction is negative. If into is positive, out is negative. If out is positive, into is negative. Now it is coming positive and we are taking the positive as the out, so it is outward. Right? Copy this. So this is the next part. Right? Here, this is the infinite wire. Fine. And it move in a circle. Right?
Yes.
And it move like this. Right?
Yes.
And this is the point O. All right? This is the current carrying I. Is it clear or not, you tell? So, how to find this? Listen one thing. You just join this wire. You may assume from minus infinity to infinity, this is the one infinite wire. All right? This is the one infinite wire. Fine? Infinite wire. Is it clear or not, you tell? And if you consider this the coil, complete coil, all right, this is the complete coil. The current is what? Say I. Is it clear or not, you tell? So now there are two parts. One is the infinite wire, right? And there is another part, and this is the circular coil. Fine. So because of this one part, this radius is what? Distance is r. So because of one part, the magnetic field is out. So B1 is what? Mu naught I upon 2 pi r, and it is out. Because of this wire, out. You understand? Right. And because of this loop, current is in this way, in this way, in this way. So yes, so B2 is also mu naught I due to circle. You will say 2R. It is out. So it is out, then assume out to be positive, positive. So when at the O you find the net magnetic field, what will you write? V1 plus V2, which is equal to mu naught I upon 2 pi R plus mu naught I upon 2R. And the net magnetic field is out. Right? Copy this. Yes, yes. In the second part, right, the next part, this is the semi-infinite wire. The current is I. Then it is a circular loop like this, right? And this is the current I over here. And this is the center. Are you getting? So now consider from minus infinity to infinity. This is the one wire. Are you getting? Minus infinity to infinity. Are you getting or not? So you can consider this the infinite wire, the one portion, and this is a very small gap. You can consider this is the loop. Loop is like this. So current is in this loop is in this direction. Is it clear or not? So if you consider the one part and this the second part, and because of one part the magnetic field is what? Out. And because of this circular loop, second part, the magnetic field is inside. So this is the B1, right? The B1 is mu naught I upon, tell me what is the perpendicular distance? 4 pi R, right? It is out. And this is what? Into the board. The B2 is what? Mu naught I upon 2R. It is into the board. Is it clear or not? You tell. Fine. So which is greater? You tell. V1 or V2? B2. So you may assume the into direction is positive, then it will be negative. So what is the net magnetic field at O? B2 minus B1 is equal to, right, mu naught I upon 2R minus mu naught, wait for 1 minute. This is the infinite wire. So what is the magnetic field? Due to infinite wire, what is the magnetic field? Tell. No. Due to infinite, mu naught I upon 2 pi R. So in previous question, 4 pi R, right? So in previous question I had taken 4 pi R or 2 pi R?
2 pi R.
Yes, yes. For infinite wire, the magnetic field is mu naught I upon 2 pi R, right? So it is mu naught I upon 2 pi R. If you take mu naught I upon 2R common, so it is 1 minus 1 upon pi. And the net magnetic field is, which is greater? Into. So net magnetic field is into the board, right? Copy this.